Hello, this is 6.4C Single Replacement Reactions. Today's objective is to identify and predict products of simple single replacement reaction. So what is a single replacement reaction? In a simple single replacement reaction, you have a free metal. The free metal is going to replace the metal ion in a compound. So the general formula is this. You have a free metal, right? And then you have a metal inside of a compound, and they're going to switch places. Once they switch places, the B that's attached to the compound ends up being that free metal. All right, so the A and the B, they switch places. You can see this in the animation. Alright, so this is what the full single replacement reaction looks like. You can see that the A and B switch places, the B ends up coming out, and that ends up being the free metal, and then A and X end up being a compound. So with this, you want to be able to predict the products. So when doing this, you can see our first example where we have zinc plus copper chloride. So in order to predict this product, you know that this zinc is going to replace the copper, all right? The copper in this example is bonded to a chlorine. So our products are going to look like this. You're going to have zinc bonding with chlorine. All right, zinc has a positive 2 charge, chlorine has a negative 1 charge, so when they bond, it's going to look like this. All right, and then we have copper, which is the free metal. This example is balanced already, so you don't need to balance it again. So the next thing you want to do is look at our next two examples. So please pause the video and try these next two examples by yourself. Alright, so you should have tried these two examples. Remember that these two metals are going to switch places. So the aluminum is going to switch places always with that another metal. So aluminum has a charge of positive 3. Alright, when this compound is made, aluminum is going to bond with our oxygen. Oxygen has a charge of negative 2. So the compound is going to look like this. Alright, and then the free metal is going to end up being our iron. Right, when you go ahead and look at this equation, you can see that it's not balanced. For now, don't worry about balancing for these. All right, their next example, we have aluminum, and it's bonded with their silver nitrate. All right, nitrate has a charge of negative 1. In this example, silver has a positive 1 charge. Aluminum has a positive 3 charge. So aluminum and silver is going to switch places. So when that happens, we have aluminum nitrate, so it's going to be NO3, 3, and that is going to leave our silver as the free metal. So not all single replacement reactions can be written, and they can actually not take place sometimes. So this is kind of the tricky part. So the key thing to remember is that the free metal must be higher on the activity series than the metal in the compound. So that's when reactions actually take place. If the free metal is not higher than the activity series, then the reaction will not take place. So let's look at this example. Will aluminum and iron 2O3 react? You can see on the activity series that the free metal aluminum is higher than this metal iron. All right, so therefore, yes, it will form a reaction. So pause the video and please balance and predict the products for aluminum when it's reacting with iron oxide. You should have tried this reaction. You know that our aluminum and our iron are going to switch places. All right, so this is going to switch places with that. Aluminum has a positive 3 charge. Oxygen has a negative 2 charge. We did this example in the previous example. So it's going to look like this. Aluminum 2O3 with a free iron. You can see that we have 2 irons on the left side, so we're going to go ahead and put 2 irons on the right side. We're going to count for this, 2 aluminums to balance this out, and 3 oxygens are on both sides. So this would be the full balance equation. Please pause the video again and try these other 3 problems. Alright, so you should have tried these 3 problems. You can see that we have PB and we have iron. Alright, so PB and iron is going to switch places. When that happens, we can see that on the activity series, the free metal PB is actually lower than our iron. In order for this reaction to take place, PB should be higher, more reactive than our iron. So therefore, this is going to result in no reaction. This reaction cannot take place, right? Looking at the next example, we have our zinc and our hydrogen. You can see that hydrogen is over here, zinc is higher than our hydrogen, therefore the reaction will take place. So these zinc and hydrogen are going to switch places. So when doing that, zinc has a charge of +2, chlorine has a -1 charge, so our compound is going to look like this. Alright, we know that hydrogen is part of our Hankel-Briff, so therefore it's going to have an H2. Alright, then we want to go ahead and balance this equation. So we have 2 hydrogens, so you can put a 2 in front of there, and then therefore now we have 2 hydrogens and 2 chlorines. The next example, we have our zinc and our magnesium. Zinc should be higher on the activity series than magnesium in order for this reaction to take place. You can see that zinc is over here and our magnesium is over here. Because zinc is lower on the activity series, again, this will result in no reaction. Please go ahead and complete the questions on the practice worksheet. If you need help, go back to the PowerPoint presentation, ask your table partners, and then lastly, raise your hand and ask the teacher. Thank you.